So dear students, we will now resume with the slide. Yes, we were here. So we are actually talking about the 8-hydroxyquinolines. We have seen the general applications and the mechanism of action. Now we'll see two examples with the IUPAC name. So this is a type of quinoline ring and 8-hydroxyquinoline. The numbering starts from nitrogen, obviously, having minimum number to the heteroatom. So 1, 2, 3, 4. At 5 position and at 7 position there are two iodo groups. So it is 5,7-diiodo 8-hydroxyquinoline. The name is iodoquinol, which is a common name. The second drug in this particular category is called cleoquinol or quinidochlor, and this is having a chloro substitution and iodo substitution at 5 and 7 position respectively, with the 8-hydroxy as a parent molecule. But unfortunately, these the drugs under this category are banned. The most commonly and popularly used drug is enteroquinol. Enteroquinol is basically belonging to the 8-hydroxyquinoline, and this is being sold in the market. Okay, it is an over the counter product. It is a very good anti-diarrheal, but actually it is globally banned. So there are many drugs which are being sold in India but which are globally banned, and enteroquinol belongs is one such drug which belongs to this category. It is actually causing dementia and damage to the sight. So it's lot of toxicity is involved in this. That is why this is banned, but still being sold. The third category is nitroimidazole derivatives. The nitroimidazole derivatives, these are effective against the as luminal amebicides, as well as these are effective against the systemic amoebiasis, both the categories. And the popular ones are metronidazole, tinidazole, and timorazole. So what are these drugs? These are the broad spectrum antibacterial and antiprotozoal agents. So these are resembling just like antibiotics, but these are like sulfonamides. These are broad spectrum antibacterial and antiprotozoal agents, and basically they are used in the pre-operative and post-operative surgeries in the hospitals. Basically, it involved in many serious infections such as abscesses, septicemia, then pneumonia, peritonitis, pelvic infections, meningitis, and many more. So you can see it's a wonder drug. Metronidazole, it is sold by the name Metro. So frequently, if you have any relative or anybody in your home who is being hospitalized, just remember one thing: there is one drug which is given through IV route after the surgery. Maximum post surgical operations मध्ये this drug is given, and it is called as Metro का इंजेक्शन मतलब क्या है कि कोई एब्सेस निकाला है या कोई मेजर सर्जरी हुई है, उसके बाद में जो इन्फेक्शन होने के चांसेस है, दैट इन्फेक्शन probability is reduced by giving the dose of metronidazole. It is also used as a radio sensitizing agent. What do you mean by radio sensitizing agent? These agents, they will sensitize the tumor, before the tumor is subjected to radiation therapy. So this drug is injected in that particular area where the tumor has grown, and the tumor will now become more sensitive to be treated by radiation therapy. तो इस पे जब radiation bombard हो जाएंगे, then good results will be obtained and the tumor will be regressed much more easily. Then metronidazole, all these drugs are actually prodrugs. This structure which you see here is an imidazole derivative. So this is an imidazole ring wherein R1 and R2 are the various groups, and this is nitro group which is attached. So it is called as nitroimidazole. R1 and R2, these are the different groups of metronidazole, tinidazole, and timorazole. In timorazole, you can see the R2 group is having one, you can say, a heterocyclic ring which is called as morpholine. So it's a morpholino analog, and at R2 substitution, and both are having both means all the three are having extremely good spectrum of antibacterial activity. So these are actually prodrugs. They are converted into reactive hydroxylamine derivative, which we'll see in the forthcoming slide. This is one example of IUPAC name of metronidazole. If you see, R1 and R2 are substituted here, CH2, CH2OH, and other substitution is CH3. Okay, it is written in a somewhat different manner. Okay, it is drawn in a somewhat different manner than that which is drawn previously. But just pay attention. Here we are having this N as 1. This nitrogen should be labeled as 1 because it is having a very bulky group. So obviously 1, then second position to methyl substituent carbon, then 3, 4 and 5. So 5 position for nitro. So it will be 2 methyl 5 nitroimidazole and 1 इल means N1 nitrogen जो first position पे है उस पे alkyl group attached है, so it is 1 इल. And what is this? CH2CH2OH, that is ethane 1 all. Okay, so this is the structure of metronidazole. Then the mechanism of action, as I have told you, hydroxylamine derivative is the actual antibacterial agent, and metronidazole, or as such the structure, that is the nitroimidazoles, 5 nitroimidazoles are prodrugs in nature. So that we'll see in detail now. The scientist Do Campo and his et al. Means his group, they postulated the they hypothesized the mechanism of action of nitroimidazoles, means this MOA is applicable to metronidazole, tinidazole, timorazole and the other variety which belongs to this particular category. These nitroimidazoles you can see in the structure. AR is the remaining group, while the NO2 is this group. Okay, तो ये जो group है ये aromatic ring करके they have labeled it, and this is the NO2. So the thing is that NO2 is important for us. Okay, while the rest of the structure, it will improve the pharmacokinetics, it will deal with the ADME of that particular drug in an order to improve the bioavailability. So NO2 is actually the species which is acting as antibacterial pharmacophore. So one electron transfer reaction, okay, this is acted upon, added up with one electron in the biological system in the of the body, and this is converted into an radical anion, that is the nitronium radical, aryl nitronium radical, upon which the O2 will attack. See, oxygen is present in ample amount in the body, so oxygen molecule, it will interact with this radical anion to form the superoxide radical anion. This is the O minus and this single unpaired electron. This super and ArNO2 is released as such to attack the different, to uptake with a single electron again and to carry out the process. Now we are interested in the superoxide anion, radical anion. This is added upon with one electron and two protons are being added up, means this particular reaction takes place in the acidic medium of the body, especially in the stomach and the upper portion of the that is a duodenum or a small intestine. And this is forming the hydrogen peroxide, H2O2. Okay, two hydrogen atoms or protons are being added up along with one electron addition to form H2O2. This H2O2 will rapidly cleave itself in the biological medium to give the two hydroxyl radicals. आता हे जे two hydroxyl radicals आहे, these are responsible actually to carry out the antibacterial activity. Next category is the ipecac alkaloids. These are obtained from the ipecac plant, Cephalus ipecacuna, and the emetin and the dihydroemetin. These are the alkaloids which are obtained from this roots of this plant. And as compared to emetin, dihydroemetin is a better drug. Okay, both these alkaloids, these have been successfully used in systemic amoebiasis only. आता याच्याआधी आपण नायट्रोइमिडाझोल बघितले, those are effective against both luminal as well as systemic, but the ipecac alkaloids, these are useful only in systemic amoebiasis. It is combined with a bismuth iodide. Okay, you take 25% of emetin and 20% of bismuth iodide, and this mixture is an effective luminal amebicide. समजा तुम्हाला इमेटिनला, if you want to have luminal amoebicidal activity, then you have to mix it with bismuth iodide. Okay, because bismuth iodide, it will decrease its solubility and it will make it more available in the GIT. The mechanism of action is it will inhibit the protein synthesis by inhibiting the transpeptidation. जो हमने tetracycline या chloramphenicol का mechanism देखा है, in the same way it will it will bind to the tRNA on ribosomes, and it will be inhibiting the process of supplying the information for protein synthesis, for bacterial protein synthesis to the messenger RNA. Okay, then chemically if you see, it is isoquinoline ring which is attached to another isoquinoline ring through a CH2 bridge. This CH2 bridge which I am encircling, this is called as methylene linkage. ये methylene linkage से ये क्या है? This is tetrahydro isoquinoline ring, and the upper one is hexahydro benzo isoquinoline ring. This is benzo and this is the isoquinoline ring which is hexahydro. Hexahydro means यहाँ पे 3 डबल बॉन्ड पे हाइड्रोजन ऐड हुए हैं, सो 3 डबल बॉन्ड मीन्स 6 हाइड्रोजन आर एडेड, सो इट इज हेक्साहाइड्रो। और यहाँ पे 2 डबल बॉन्ड पे हाइड्रोजन ऐड हुआ है, सो इट इज 2 double bond means 4 electrons means 4 hydrogen atoms, that is why it is called tetrahydro isoquinoline ring. Okay, now you can find asymmetric carbon atoms at 4 different positions. This is the first position, okay, this is 1 dash position, then this is 2 position, asymmetric carbon means carbon atom with 4 different groups, and this is the third one. याच्यात चौथा ग्रुप कुठला आहे, हायड्रोजन आहे, and this is 11b which is having the 4 different substituents. Whatever configuration, whatever arrangement is written in the slide, ये जो structure draw किया है, this is the ideal conformation, means the most favored conformation. And there are two alkaloids as we have already discussed, एमिटिन एंड डिहाइड्रोएमिटिन. एमिटिन अगर है तो R1 इथिल और R2 मिथॉक्सी है, और डिहाइड्रोएमिटिन है तो भी यही ग्रुप्स है, R1 इज इथिल एंड R2 इज ओमिथिल, बट C2 एंड C3 के बीच में डबल बॉन्ड आएगा, मीन्स ये हाइड्रोजन इज लॉस्ट, एंड दिस हाइड्रोजन ऑफ द थर्ड पोजिशन कार्बन इज ऑल्सो लॉस्ट, मीन्स डिहाइड्रो. डिहाइड्रो मीन्स 2 हाइड्रोजन एटम्स निकल चुके हैं, एंड R1 and R2 will remain same. Toxic effects, you can see lot of toxic effects, CVS effects, GI distress, neuromuscular effects, and all these things are there. So that is why ipecac alkaloids, emitin and dihydroemitin, these are the last choice, okay, to treat the amoebiasis. Then antibiotics are there. Paromomycin is one of them, obtained from Streptomyces rhemosus. It is having a very wonderful trophocytocidal action. It will destroy the enteric bacteria required for the growth of trophozoites, and it will interfere with the RNA and DNA synthesis of protozoa. The next category is organic arsenical. You can see arsenic. Arsenic actually is a very heavy metal, and it is a slow poison. That is why these organic arsenicals are not much used. आता याच्यामध्ये क्लिनिकली एकही मेंबरचा यूज होत नाही, बट इट इज ऑल्सो वन ऑफ द केमिकल क्लासेस, दॅट इज वाय वी आर स्टडिंग. So arsenic actually is having amoebicidal action. How does it act? It will inactivate the enzymes of amoeba which are having sulfhydryl groups in them. तो जहाँ जहाँ अमीबा के जो एंजाइम्स है, वो एंजाइम में, एंजाइम इज मेड अप ऑफ अमाइनो एसिड्स, इजंट इट, इट इज प्रोटीनस इन नेचर. तो उसमें जो सल्फेड्रल कंटेनिंग अमाइनो एसिड्स है, जैसे सेरिन है, सिस्टीन है, सो दीज आर फॉर्मिंग कॉम्प्लेक्स विद द आर्सेनिक As3+, and arsenic complex will be, the arsenic is then reduced, oxidized to As5+. Okay, toxicity itself, as I've told you, is the presence of arsenic itself. These are the two carbarsone and acetarsole examples. This is 4-acetamido, okay, phenyl, and this portion is arsenic acid. Okay, this is 3-acetyl, then 4-hydroxyl, and phenyl arsenic acid. Synthesis of trinidazole, this is a sulfur containing ethanol, so thioethyl ethanol is the starting material. It is treated with peracid, a very strong oxidizing agent, जहाँ पे sulfur is oxidized to SO2, and then it is treated with tosyl chloride. Tosyl chloride is to convert the OH into OTS. Okay, OTS is a very good leaving group as compared to OH, because it is a very good electrophile, it is removed very easily, and then it is minus TSOH से क्या होता है कि this ring is formed. Okay, when it is treated with a pyrazole nucleus, this pyrazole nucleus, H of the pyrazole, the pyrrole nitrogen of the pyrazole is replaced with this entire group, मतलब H and OTS निकल जाता है to form TSOH, और this remaining group is substituted here. This is the structure of tinidazole. Synthesis of metronidazole, ethylene 1,2-diamine, this structure is there as starting material. It is treated with methyl cyanide and in presence of zinc dust, and cyclization takes place. So this is CH2CH2, यहाँ से 2 हाइड्रोजन निकलते हैं to form CH डबल बॉन्ड CH, 2 हाइड्रोजन निकल गए, यहाँ से 2 हाइड्रोजन निकलते हैं, मतलब 4 हाइड्रोजन, एंड ये एक हाइड्रोजन, so N double bond, and then CH3. So it is 2-methyl-1H imidazole is formed, which upon nitration and treatment with phosphorus pentoxide, it is going to be nitrated at this position, because among all the 1, 2 and 3 position remaining for nitration, this position is more electron dense because it is surrounded by the nitrogen which is having a pyrrole type nature, so it is more electronegative. So nitration मतलब क्या है, electrophilic nitronium group, this is an electrophile, So electrophile will attack to that carbon which is more electron dense, which is this electron, this carbon is more electron dense. So nitration will preferentially take place on this particular position, which upon treatment with what is this? This is chloroethanol. Okay, two chloroethanol. Upon refluxation, this hydrogen is replaced and this chloro is replaced and lost as minus HCl, and यहाँ पे CH2OH is being put. Okay, so we'll stop here. We have finished with the anti-amoebic chapter. Thank you.